know that brains can perform in the same way as anyone else's brain. I always like to say to people, we're not broken, we're just inconsistent. So it's not that we can't focus, it's not that we can't direct emotion, it's not that we can't organize working memory, it's just that it doesn't happen reliably. We can use that attention to create a new decision about what we're going to do next. And then we do something really cool. We summarize that into a new emotion. If I need access to dopamine to turn on my attention and I know I don't have it, then it's going to be hard to shift from default mode to task positive. So our attention is not turning on as strongly as it could, but at the same time, our default mode is staying fired up.
Hello, welcome back to the Smart ADHD Podcast. Today, we're diving into a fascinating topic, the neuroscience of ADHD. And joining me is the amazing Jonathan Hassall. This was such a fun conversation. He is an ADHD and executive function coach and director of Connect ADHD coaching all the way from Brisbane, Australia. Jonathan has a wealth of experience in psychiatric services, ADHD coaching, and even served as a scientific advisor for ADHD in the pharmaceutical industry. He's also co-authored the book Decoding Doing, Solving ADHD and Procrastination. So in this episode, we're unpacking the neurological side of ADHD, what is actually going on in our brains. Jonathan explains some words that you might have heard about before, such as the prefrontal cortex, and how understanding the roles of dopamine and our brain's networks sheds some light on some of our most common struggles. We'll be exploring how these brain functions affect things like time management, anxiety, and the fight or flight response, and how medication can help manage those challenges. Let's get on with it right now. Hello, John. Welcome to Smart ADHD. How are you doing?
I'm doing wonderfully, thanks, Ian. Thanks for having me.
Oh, it's been great to have you. We've only just recently met. We had an amazing conversation. My head was blown last time we spoke. In fact, I went downstairs for lunch and saw my wife, and she saw that my head had exploded. After all of what we were talking about, it was so interesting. And so I wanted to get you onto the show to talk about neurology, neuroscience, neurochemistry, whatever you want to call it. And I'm going to ask you about that in a bit. So I suppose my first question to you is, why is it important for us to have an understanding of the neurology, what's happening in our brain from that perspective? How does that help us as people who have ADHD?
Thanks, Ian. That's a great place to start. So I think the thing is, ADHD has been shrouded in a lot of mystery for a long time, and still largely is, because we've always had to describe it from what we see as a behavior and tried to interpret that. Now, that's very useful for diagnostics because it helps us categorize what we see as consistent behaviors. However, if we want to have an effect on changing it, we need to understand the mechanism behind the condition. And if we can understand the mechanism, then we can perhaps start seeing how we could influence those mechanisms to get better outcomes for ourselves.
Yeah, now that's really interesting. And what we're going to try and do in this episode, or what you're going to try and help us with, I think, is there's all these words that we've heard, like dopamine and all these other things that we're going to talk about. And there's a lot of misconceptions, mysteries about all of these things. Now, one thing that when we were chatting last time, I was using the word neuroscience and you were using the word neurochemistry. And I thought, oh, that's interesting. And then I started getting me thinking, maybe that's because of these chemicals in our brains, we mentioned dopamine. So why do you refer more to neurochemistry rather than neuroscience when discussing ADHD?
I think neuroscience is a factor in neurochemistry is a factor in neuroscience. I suppose my bias in terms of discussing it is twofold. One, I come from a pharmaceuticals background originally, and so a lot of that was about neurochemistry, is particularly what we're focused on. But I think the other part is too that with ADHD, primarily we're looking at neurochemistry. We're not seeing a particular difference at this stage anyway, in structural or functional features of the brain. What we're seeing is an inconsistency and availability of a particular neurochemistry. And that neurochemistry is very responsive to a whole pile of conditions that happen both within the body and outside the body.
Yeah, that's fascinating, because I've thought about ADHD as there's something structurally different about my brain, but actually what's really interesting is going into the chemistry, what inside my brain. And so, yeah, that's a really helpful distinction. So from a neurological point of view, can you break down what ADHD looks like? What's actually happening in our brains?
Now, I misspoke slightly. There probably is a minor structural difference, but which is directly related to the neurochemistry. However, I don't think of it as a major structural difference because we know that our brains can perform in the same way as anyone else's brain. I always like to say to people, we're not broken, we're just inconsistent. So it's not that we can't focus. It's not that we can't direct emotion. It's not that we can't organize working memory. It's just that it doesn't happen reliably. So currently what the research suggests is that in terms of neuroscience, ADHD is highly hereditary. It's right up there with height as the most inheritable thing you can have. The second part of it is that what we think is happening is that we're getting inconsistent availability of dopamine, which is largely due to the fact that we're effectively recycling dopamine too efficiently. Now, the reason we think we come to that little, if there is a neurological difference, is that we think we have more reuptake receptors than other people do. So if you think about a dopamine system, there's receptors where we release dopamine and they go out and they impact with the other receptors to pass on signals. But then we also have this process of what we call reuptake pumps. And these reuptake receptors, their job is to reabsorb dopamine. And we think that people with ADHD have too many of them. Now, one of the reasons that we came to that conclusion was that the medications that we've found effective with ADHD, particularly the stimulants, effectively block some of those reuptake receptors. So with the stimulant, you're not replacing dopamine. What you're doing is you're stopping your dopamine being reabsorbed. So what does that mean? So if we think about dopamine as a bit of a universal communicator, that it's passing signals between receptors. And keeping in mind, it's not one receptor to one receptor. It's one to hundreds or even thousands. And so when it does that, what we're doing is we're interrupting the signal in our brain. Now, the area of the brain that we think is primarily affected is the back part of the prefrontal cortex, which is what we're associating, theoretically, with effectively something we call executive function, which is about how we self-regulate our thinking. So therefore, that's where we get problems with directing our attention, with directing emotion, with managing working memory or capacity of working memory, and then in turn other particular functions like organization, time awareness, and all that sort of thing.
Okay, I think that's so interesting. And I hadn't thought about the fact that we have too many receptors. This is the kind of current thinking. I've always thought, well, maybe we just don't have enough dopamine. But I suppose in a way that is the case. So there isn't enough dopamine for the number of receptors that we have. What is the role of dopamine? I hear a lot about it being talked about when it comes to like motivation, but what is its role in our brains?
And I'll speak just to my knowledge and experience. And the thing is that it's popularized as the woohoo neurochemistry or the yeehaw. But basically, I ran into a neural researcher years back here at the Queensland Brain Institute, and he was very excited. And he said, we've just found this amazing thing that dopamine is in most parts of the body. In fact, it's everywhere where there is nervous tissue in the body, and that it's more appropriate to think of it as a universal communicator, that it's passing signals. That's its job. And when we think about how the brain is set up, that we have effectively brain cells that come down to receptors, but they don't actually all connect to each other, because if you think about it, and again, theoretically, that would not be a good model for a brain because it'd be very limiting. We'd be like hardwired. But instead, we've got this neat little system that instead of being permanently wired to each other, we pass on the electrical signal between brain cells by spitting bits of neurochemical across that passes on the information or re-triggers the electrical stimulation in the other brain cell, which means we can have one cell talking to hundreds of others and mediating that in a really very eloquent way, which is why our brain can do the amazing things it does. Yes, dopamine is very much affected in terms of stimulation. It's certainly very much present in terms of the reward centers of the brain. In fact, that's one of the features when we look at stimulant treatment used appropriately is very much therapeutic. We know that it still affects increasing dopamine availability throughout the brain. So it does have the potential to have a sensory effect in terms of that's where you have to be careful about potential for misuse. So dopamine's a really interesting neurochemistry, and there are other very interesting neurochemicals as well. However, dopamine has been fairly unique in that it's very we talk about it very selectively with ADHD, but it gives us a very neat target, if you like, for change. For example, everybody's dopamine fluctuates, everybody. And in fact, we've all seen examples. If you want to see someone who's got poor dopamine availability, pick someone who's been up all night, somebody with a newborn. They're running on low fuel. If we look at somebody who is intoxicated, if we look at somebody who is hungry, the whole hangry meme that we seem to have now that never used to exist, under a lot of stress, what we're going to see is a lot of cognitive poor self-regulation. So we see people being more emotional. We see people having trouble with their attention. We see people struggling with working memory to hold concepts in mind and manipulate them. We see them struggle with organization and perception of time. Now, the difference being that for people without ADHD, these are transient events. They're usually quite reliable, that they know exactly why they're happening. I stayed up all night, that's why this is happening today. And the other thing that they do, which I think in coaching is a particular interest with ADHD, is that they have cognitive systems to accommodate when their dopamine availability isn't as good.
Interesting. So would it be fair to say that with ADHD brains that we have lower amounts of dopamine, but that it does, again, it fluctuates. Sometimes if we're just in a hyper-focused state, then our dopamine goes up, or we're excited about something, our dopamine level goes up, but that it fluctuates. That's the kind of first part of the question. But the second part of the question is, what happens when we have very low dopamine? I guess I know what that's like, having ADHD. I know how that feels, but what's actually happening in the brain?
I think we've got to be careful of this association with dopamine as being, we've got dopamine, we're excited, or we're charged up. If we think about it from a self-regulatory approach, so it's more about how we regulate all those things. So if we're too excited, that's not good. Bad things happen when we're too excited, right? But also good things can happen when we're appropriately excited. Just like it is great to put our attention on things, but it's also great to be able to switch our attention. So we talk about hyperfocus versus being able to shift attention. So in terms of dopamine availability, effectively there's probably this relative line in the sand that anyone can dip in a crossover, in which means they're going to have less effective communication, which means less effective self-regulation. So that may look like someone being very emotional. It may look like somebody being very distracted and vague. It may look like somebody having trouble holding procedure in mind and that sort of thing. The difference, I think, with ADHD, and the way I like to think about it, is because that we seem to have greater recycling of dopamine, or we're closer to that line all the time. And then you compound that by the fact that we have behavioral habits because of our poor self-regulation that further impact it. So poor sleep, poor diet, poor exercise, poor stress management. All of those things will actually decrease dopamine availability too. So it's like a compounding problem. Whereas someone without ADHD will have better availability of dopamine, but it's more consistent. So they're able to fuel their self-regulation better, but also too, like I said, they're more likely to intuitively develop cognitive systems to self-regulate.
Yeah, that makes sense. I think there's a lot of misconceptions and myths about dopamine, and it's a complicated thing. So you've mentioned the prefrontal cortex, I think, a few times. And again, this is something that I hear a lot, that I've heard people say that we don't have reliable access to the prefrontal cortex. I don't really even know what that means. But what is the prefrontal cortex, and what's happening there for ADHD brains? You've mentioned executive functions and planning, and that's what tends to be happening in there. But from a neurochemistry, neurological point of view, what's going on?
Prefrontal cortex, basically we're describing a geographical area of the brain. And in this case, we're talking about the part that's right behind your forehead. And that part of the brain we think developed a bit later in humans. It's allowed us to do a lot of very directed attentional tasks. It probably has a role in terms of things like object permanence. So in other words, we can visualize things, we can imagine things more effectively. But in the context of ADHD, we tend to talk about prefrontal cortex in terms of attention. And then as we go back into the brain, we go back through the rear of the prefrontal cortex and we get back towards the center of the brain. We're actually looking more at emotion. And so in between that, there's some sort of crossover, which is what we theorize is the seat of executive function. Keeping in mind, executive function is a theoretical model. We don't know that there's an executive function brain or part of the brain or anything else. But what it's come from is an interpretation of how people are observed to self-regulate their behavior, and particularly the relationship between emotional regulation and attentional regulation. So if we think about that, then we think about what current theory around emotion is. And if you want to look at some great research on this, Lisa Feldman Barrett has been doing wonderful research for many years and is very, very popular now in terms of redefining how we interpret what emotions even are. It's not to do with ADHD, but it's always interesting to look outside of ADHD. When we want to look at that relationship, we have to start moving into thinking about a new way of looking at the brain, which is called neural networks, which I think has got far more utility than just the straight old, the emotional center to an attentional center, because it actually incorporates far more areas of the brain. But once again, in terms of us understanding or trying to interpret what we're seeing in our behavior, it's far more useful because we can, again, look at manipulating it.
Yeah, fascinating stuff. And I think, we'll maybe talk a little bit about that more when you come onto the podcast again to talk about motivation and things like that. So fascinating stuff. The next thing I wanted to ask you about, which I've only started to hear about relatively recently, and maybe it's been around in the neuroscience world for ages, but this is what's called the default mode network and task positive network. So I think it's DMN and TPN. I always get really confused about these. So what are those things and what's going on again in our brains with ADHD?
So they're the neural networks, two of the neural networks I was referring to. There are more than two. I think there's at least 7 last time I looked. But it's a new emerging research area. When I left pharmaceuticals and moved into coaching, it was very new. So we're talking about 12 years ago, we're seeing a lot of the research starting to come out. But basically, it's looking at the brain in a different way because it's looking at it in a very functional context, and where we've got a new opportunity to see how the brain works through things like functional MRIs, where we can actually see the electrical functionality of the brain as it's working. So you can strap someone up, get them to do a task, and actually see what parts of the brain are lighting up and in what order, which is very cool. And once again, we're observing something and trying to understand it. And you get someone who's doing current research in the area who could describe it far better than I. But at a functional level, for me, I look at it from default mode network is basically our walking around network. It's basically around the limbic region going back to the cerebellum, and a little bit into the prefrontal cortex or the back of the prefrontal cortex. And what makes that interesting is that, okay, that's where we used to have emotions. It's also where we have access to the amygdala, which traditionally has been associated as a fear center, although more current research talks about it as a contrast center, which is important. I'll explain why in a minute. And then the cerebellum is about memory. So one of its big features is about memory. So in a very simplistic way of looking at it, the default mode network allows us as one of its features to walk around, see a contrast in our environment, something that stands out as different. So that's where I think it's more useful to look at the amygdala in that context rather than in a fear context. Because fear is the end result. It's the end emotional interpretation. It's not actually what the functional part of the brain would be. So then if we go back from there and think, okay, so I'm walking around, I see a contrast in my environment. Let's say it's a throaty V8 engine roaring in the street and terrifying all the Teslas. Now, if I was ever... Now, that's going to alert to me there is something out of the ordinary in my environment that deserves my attention. Now, what I'm really trying to decide very quickly, is it motivational? What form of motivation does it stimulate? Is it something I want to motivate towards or something I want to motivate away from? Is it got opportunity or threat? So the default mode then, and this is what we think it's doing, is accessing cumulative memories that we have in a very rough, fuzzy logic sort of way to say, what does that remind me of? Now, if I got run down by a V8 at some point in my life, it probably is not going to remind me of something good. So I'm probably going to have a very adverse immediate response to it. Like I won't even think about it. It'll make me jump. Right? However, if I happen to be a bit of a motorhead and love a big throaty engine, it might be something I want to motivate towards because I've got a very positive association with it. And obviously we form these associations based on the frequency that we get them, but also with the emotional significance of them, where you see where people with a lot of trauma can be very quickly and very significantly conditioned to a response because it was such a profound experience for them. So that's default mode. So that's a really fast and dirty way of seeing the future. However, it's based on the past. It's not prospective. So if we just did that, we'd be running around reacting to everything, which probably wouldn't work out most of the time. So what we do is we have access to our attention. So remember we said prefrontal cortex, the task positive network, which is also referred to as the central executive in some areas, is where we turn on attention effectively. So we have to switch from this default mode network and transfer over to the task positive. And the fMRI scans that I've seen of it show a significant reduction in the default mode as we turn on the task positive. So what that suggests is we're turning down an emotional response. So we're turning off the alarm to turn on attention to look at detail. Because you ever tried to look at detail with an alarm going off in the back of the room? Like next to impossible. So you focus on the detail. Now we're seeing stuff here and now. We're still seeing it with a bit of bias, of course, because we can't escape that. But basically, we're now looking at it more objectively. And when we look at that, we can make a more informed decision. Okay, maybe I did get run down by a V8 once, but I look at that V8 and, oh, it's actually a pretty cool looking car and there's a nice looking person driving it. And now I'm thinking, oh, I might want to go and have a look at that car. Now I've decided it's not a threat. It's something that actually has other appealing factors that I might go and check out. So in other words, what we do is we can use that attention to create a new decision about what we're going to do, agency about what we're going to do next. And then we do something really cool. We summarize that into a new emotion. We associate a new emotion with that sound. Now that's not such a bad sound. It might be benign or it might be even appealing. And if you think back, there's lots of examples through life where you can remember times something that you maybe were repulsed by, but when you looked at it in a different light or had a different experience of it, you're able to create a new association with it. And I think that's a really exciting opportunity for growth, emotional growth.
Definitely. So in the ADHD brain, I've heard that we tend to be kind of locked more in the DMN network more than the task positive network. Is that true? And how do we get more towards the task positive network when we actually need to get stuff done?
Yeah, so I suppose we careful how we talk about it, I guess. I think you described it pretty well. But it's more like that. So if we think about how do we move from default mode to task positive, so it appears that we require more energy to turn on the attention. And I think this is what's fed some of the theories around it being a later evolution in our brain. The whole lizard brain thing is not real. I think that the current research doesn't support that. But definitely our brains have changed as we've evolved as animals. But if we think about that, we need energy to turn on that. In other words, dopamine. We need availability of dopamine to turn on attention. We don't appear to have a dopamine problem in that default mode network. With ADHD, that system is up and firing. And if we think about this, that if I need access to dopamine to turn on my attention and I know I don't have it, then it's going to be hard to shift from default mode to task positive. And in fact, there was some small, I haven't checked it lately, but there have been some small studies, fMRI studies done, where they've shown that as the task positive network activates, the default mode network doesn't turn down like it should. So the task positive isn't as robust in its activation. So our attention is not turning on as strongly as it could. But at the same time, our default mode is staying fired up, which the suggestion from that research was it might be why we remain so distractible when we're focusing on things.
Yeah, really interesting stuff. And I do want to get back to your thoughts on making emotions, because that is mind-blowing. But we maybe talk about that in the next episode. We're almost out of time. In fact, we are out of time. But I do want to quickly ask you, but there's a few other things. So maybe if you could, this is an impossible task to go through this really quickly. But there's the parasympathetic and the sympathetic nervous systems. I always get these mixed up, but one is described as the fight or flight one and the rest and digest one. Yeah. So how are those affected by ADHD? I find that tend to be in the fight or flight mode a lot and that kind of the anxious state. And I find it difficult to switch back into the rest and digest sometimes. Is that an ADHD thing? What's going on?
Yeah, again, we're talking about a functional outcome of ADHD. And it depends on the person with ADHD. I know there are a lot of people out there with ADHD who, particularly inattentive, who may spend much more time in parasympathetic and don't get riled up very easily at all. But in terms of when we are having that fight, flight, freeze response, and my wife actually wrote she's Monica Hassall, she's also an ADHD coach. She's written a fantastic paper a few years ago called The Fourth F, because she proposed that there was a fourth F in fight, flight, and freeze, which was fib. In other words, we tell fibs or lies to fend. And if you look at kids, the kids do it, but we do it as adults. And they're not manipulative lies. They're more like defensive misleadings or fabrications. But if we think about that state, what we're doing in that state is, yes, you're getting an adrenaline hit, you're going into some sort of self-preservation. It's usually heavily attached to anxiety. And I've got to say, anxiety is prolific amongst people with ADHD. And even if very commonly people aren't aware that what they've been experiencing is anxiety. I had a client today, a very clever person who has obviously been ADHD her entire life. And when we talked about anxiety, she suddenly thought about it and thought, oh my goodness, was that anxiety? Was threatening myself to do things, worrying that if I didn't do things immediately, it would fail, forget. Was that anxiety? And then she said, was this great sense of negative pressure on me all the time? Was that anxiety? And I said, yes, definitely. So that's that system that we're utilizing. So there's two things to think about that. One is in the appropriate measures, it's a very useful system. Every neurological system is useful, right? But even distractions are useful in the appropriate context, right? But the problem with ADHD is that, as you mentioned, we can find ourselves pushed into that space too often because we get there when we feel out of control, which if you have an inconsistent dopamine availability, you are going to feel out of control because you're not self-regulating effectively. The other thing to think about too is if you look at things like cortisol, we know that as cortisol levels increase, that's very useful to us because cortisol helps us activate and solve problems. But when we can't solve the problem, it goes too high. And when it goes too high, it suppresses dopamine availability. So we now are getting stressed and we can't think straight anymore. So what do? We flick back into the 4Fs and we react. And that's what we do. Now, but an interesting alternative byproduct of that I've seen with ADHD, and I see this very commonly in intelligent women, not exclusively, but I just see my clinical experience is predominantly more intelligent women, is that women get very good at using anxiety as an activation tool. That's self-threat, that if I don't do it now, I'll fail, or I'll make sure I bring everything forward as though it's due tomorrow, and that makes me activate. Unfortunately, that doesn't keep working, but it seems to be effective to a point for them, but at a significant cost. That would be something I would be very conscious of changing, because I think that is one of those things that is that the big unseen of impact of ADHD. And often it gets written off as this other anxiety, but often my experience has been they're very correlated.
That's fascinating. Dr. Tamer Wazir was talking about the 6 bad tools that many of us kind of use as a motivation technique, and anxiety is definitely one of them. Yeah, I might have been known to use that myself a few times, but we are out of time, Jonathan. Oh my goodness. I just feel we've only just dipped our toe in this world. I think we probably need a part 2 in the future, and we can go deeper. Thank you so much for sharing all your thoughts with us. You do have an amazing book. I've got it on order. It's called Decoding Doing ADHD Solutions for Procrastination. We're going to talk a little bit more about that in the next episode on that. Thank you so much, Jonathan. Any kind of final words of encouragement? Obviously, we've talked about the neurology here, but what would be your kind of final message for people who've been listening, that there is hope and there is a way forwards with all of this?
Absolutely. First of all, Ian, thank you for having me, and thank you for doing this podcast, because it's these sorts of conversations and having had Tamara on recently, and she's wonderful. And so having these sorts of conversations are invaluable. The thing I'd say to everyone out there is, whatever you know about ADHD, there's always more to learn. However, the secret is, I think, we want to get ourselves to a point where we achieve our intentions reliably. Our intentions invariably are the right thing to be following, and they're the measure of who we are. We can learn to self-regulate more effectively. So those biases, some people call them superpowers. I prefer to think of them as functional biases. We can use them to our advantage instead of our detriment. Please, the reason I work in ADHD is because people with ADHD are nothing but unrealized potential. And with even the fact that you've achieved heaps already, there's so much more that you can tap into. And most importantly is a very happy and rewarding life.
Awesome. Thank you, Jonathan. You can find out all the show notes for this. You can connect with Jonathan. Just go to smartadhd.me and find this episode, and all the details will be there. Thank you, Jonathan. And until next time, I encourage you to be smart with your ADHD. Toodaloo.